Hi, my name is Gauri Shankar. Today I'm going to say about converting ER diagrams to relation schema. On converting ER diagram to relation schema, we have strong entity types and weak entity types. So in that first, from converting strong entity types, for that we have to follow these steps. Each entity type becomes a table. Each single valued attribute becomes a column. Derived attributes are ignored. Multi-valued attributes represented by a separate table. The key attribute of the entity type becomes a primary key of the table. So for that, for the strong entity, we will take an example. Here is an details about employee table, and we have the attributes name, door number, street, city, pin code, date of joining, year of service, and skill set. So here address is a composite attribute, year of service is derived attribute, skill set is a multi-valued attribute because an employee can have more than one skill, so it has multi-valued attribute. The relation schema: employee name, door number, city, pin code, date of joining, and employee slash will be the primary key. Entity example. So further, employee table will have employee code as primary key, employee name, date of joining, skill set, and in the skill set, employee code is a foreign key for the employee table and skills. So in that we have weak entity types. So converting weak entity types into relation schema. Weak entity types are converted into a table of their own. The primary key of the strong entity acting as a foreign key in the table. The foreign key along with the key of the weak entity from the table composite primary key of the table. So for that it has 1 to n. Employee has n dependents. That means dependents we have ID, name, address, and the relation schema. So employee will be the primary key, and dependent employee, dependent ID, name, address. And so here is an example about that weak entity types. Employee table, in that employee code will be taken as primary key, and in the dependents of the employee code will be taken as both primary key and foreign key, and dependent ID will be a primary key only, and the converting relationships. The way relationships are represented depend on the cardinality and degree of the relationship. So there are three cardinalities: 1:1, 1:many, and n:m. The degrees are, so these relationships have some degrees: unary, binary, and ternary. So first we talk about binary, 1:1. So employee, so in this we have the department and the employee manages the department. So the combination of participant, we have two cases. In case one, combination of participant types, the primary key of the partial participant will become the foreign key of the total participant. Employee is E will be the ID, and in the department MGR E slash will be the foreign key of the employee table. In this there is another example, binary 1:1. So in this, an employee sits on a chair. Case 2, uniform participation types. The primary key of the either of the participant can become a foreign key in another. That means employee name and chair, item. The chair, it has item, model, location, and which employee it can use it by. So for that, use it by will become as a foreign key for that. So binary 1:1, employee table and chair you will have. So employee code, employee name, date of joining, and skill set, and chair it has some attributes: item, item number, model, location, user by. So employee code will become primary key and user by will become foreign key. Employee table, chair. So in the other case, employee code, name, date of joining, skill set, and sit on. So further, employee code will be primary key and sit on will be a foreign key, and item number will be a primary key. So in the other case, binary 1:n. So is one teacher teaches n subjects. So 1:n. The primary key of the relation on the one side of the relationship becomes a foreign key, in the name subject code. So in the teacher ID will be a primary key, and the subject in the subject wise attributes subject code will be a primary key and teacher ID will be the foreign key, which is related to the teacher ID in the teacher table. In binary emission, student enrolls course. So student can enroll many courses. So a new table is created to represent the relation, contain two foreign keys, one from each of the participants in the relationship. The primary key of the new table is a combination of the two foreign keys. Primary binary emission, we have course ID, course name. So one student can enroll more than one course, so that student code will be both act as a primary key and foreign key, and course ID will also act as a both primary key and foreign key. And in the student table we have student ID, student name, date of birth, address, and self-referencing. Self-referencing can also be used to store the hierarchical data. So for that, consider an employees who are also a couple. The primary key field itself will become a foreign key in the same table. Self-referencing. So in the same employee table we have the employee and its spouse, so that employee code will be primary key and spouse will be the foreign key. So self-referencing 1:n. The primary key field itself will become foreign key in the same table, same as unary 1:1. Self-referencing 1:n. Employee code will become as primary key and manager will become as foreign key. Self-referencing m2n. This will be two resulting tables, one to represent the entity and another to represent the m:n relationship as follows. Employee /name, comma name, guarantee, guarantor or beneficiary. So that employee belongs to 2. So that is m:n. Ternary relationship. Ternary relationship is represented by new table. The new table contains 3 foreign keys, one from each of the participating entities. The primary key of the new table is a combination of all 3 foreign keys. So in this, the prescription will be related to the 3 cases, that 3 tables, that is medicine and doctor and patients. Prescription, doctor, patient, medicine, name. So in this, the doctor ID will be the primary key, and prescription in the prescription, doctor ID, patient code and medicine name will be the both will become acts as a both primary key and foreign key. And patient in patient code, which will be taken in the prescription, will be act as a primary key in the patient table, and the medicine name which have we taken in prescription will act as a primary key in the ternary table. Thank you.